Hydrogen chloride occurs naturally as a gas at room temperature. If the temperature is reduced, it liquefies and eventually solidifies. What are the bonds and the intermolecular forces found in hydrogen chloride? Well, let's consider hydrogen chloride. It's hydrogen and chlorine, non-metal, non-metal. The electronegativities are 2, 1, and 3. So you're going to land up with a polar covalent bond. So we're either in C or in D. 2 nonmetals without the same electronegativity gives you polar covalent. Then what holds one HCl onto the next HCl? Well, what you've created is a dipole with a slightly positive and a slightly negative side, slightly positive, slightly negative. Those are held together by a intermolecular force, and that intermolecular force is called a dipole holding on to another dipole. It's a type of van der Waals force, but more specifically, it is a dipole-dipole. So D is going to be your correct answer. Ammonium sulfate is a salt that is widely used in the fertilizer industry. The formula for ammonium sulfate is ammonium sulfate, NH4. We now expected to know has a valency of 1 because it would have been NH4 plus. Sulfate, SO4, 2 minus, so it has a valency of 2. If I now hold hands on those, I land up with 2 NH4s joining onto 1 sulfate. So I need a bracket for the NH4, 2, and then sulfate. So C is your correct answer. Zinc reacts with sulfuric acid to produce zinc sulfate salt and hydrogen gas. The balanced chemical equation is represented by. So I've got zinc, I've got sulfuric acid. Luckily, they haven't tried to change any of those formulas. You've got zinc sulfate. Now, here's an important thing. What is the formula for zinc sulfate? Because they're giving me different formulas here. They're also giving me different formulas of hydrogen. So before I do anything else, let's take a look. Is hydrogen is diatomic. And hydrogen is diatomic, so it's going to have to be either C or D. And then I have got zinc sulfate. If we draw that out, zinc has got a valency of 2. I need to know that off by heart. Sulfate is SO4 2 minus, so it's got a valency of 2. So zinc sulfate is going to turn out to be ZnSO4. So the only formula that has the ZnSO4 correct formula and the hydrogen correct formula is going to be C. We better just check it's balanced. 1 zinc on the left, 1 zinc on the right. 2 hydrogens on the left, 2 hydrogens on the right. 1 sulfate on the left, 1 sulfate on the right. So your correct answer is C. South African coal is considered to be sulfur rich. If 1,28 kilograms of coal are burnt, 2 moles of sulfur dioxide are produced at STP. What volume would this amount of gas occupy? So it's 2 moles. What is the volume of 2 moles of any gas at STP? It's going to be 2 times 22,4, and I land up with 44,8 decimeters cubed. So all the bump in the story doesn't make any difference. It's a very simple question about 2 moles of any gas at STP. A chemical reaction has the following energy profile. Energy of the reactants, activation energy, activated complex, losing energy, and the energy of the products. So we're interested in the activation energy. The activation energy is between reactants up to the activated complex. So in this case, it is going to be 100, and I'm going to have to add that 100. So I land up with an answer of B. 1,2 times 10 to the 24 molecules of a certain gas has a mass. Which gas is represented? So first I'm going to work out how many moles have I got. So I go number of moles is equal to number of particles over Avogadro's number. 1,2 times 10 to the 24 divided by 6,02 times 10 to the 23. I land up with 2 moles. Now I'm going to say molar mass is equal to mass divided by number of moles. Remember my triangle? Mass is at the top, molar mass, and number of moles is at the bottom. So I go 64 and I divide that by 2 and get 32. If I've got 32 grams per mole, I am not dealing with any of these because nitrogen as a gas is going to be 28, but it's 14 plus 14. Copper is going to be 50 something. Helium lands up as a lone gas being 4. Oxygen, remember, is a diatomic, so it's going to be 16 plus 16, so that is your 32. They're giving me a solution, they give me the concentration of hydrochloric acid is required for a titration. In the laboratory, a chemist has only got a certain stock solution. What volume of water would need to be added to 25 centimeters cubed of concentrated acid in order to result in the required solution? So let's see, we're going to do our normal dilution thing where we say, what have we got? I've got 1 mole per cubic decimeter, and then I'm going to be taking 25 centimeters cubed of that. So in order to do that, I'm going to say number of moles is equal to concentration times volume, and I am going to say I need to change this into decimeters cubed. So it's 0,025 multiplied by 1. And the number of moles going across is going to be your constant. So in my new container, the number of moles is 0,025, and they would like my new concentration to be 0,125. And so if I am trying to find the volume, again, let's just look at our triangle. Concentration is equal to number of moles divided by volume. So number of moles was concentration times volume. Now I'm looking for volume. So volume is going to be number of moles divided by concentration. So I go 0,025 divided by 0,125, and I land up with an answer of 0,2. But remember, that is decimeters cubed, so I better change it into centimeters cubed, and that's going to be 200 centimeters cubed. That's the total volume. I got originally, I had 25 centimeters cubed, so I need to subtract those 25 centimeters cubed from the 200 centimeters cubed. So total volume of the dilute solution less what was contributed by the concentrated solution lands up with an answer of 175 centimeters cubed. Consider the following solids: diamond, potassium bromide, ammonia, iron. Which of the following correctly describes the lattices formed in each of them? Well, let's think about it firstly. Potassium bromide is going to be an ionic because it is a metal and a non-metal, potassium and bromine. So potassium bromide is ionic. If I take a look at ammonia, ammonia is NH3, so that is non-metal and non-metal, meaning that I'm going to land up with a molecule. It's going to be a polar covalent molecule, but it's more than that. It is one of the NOF gases, so it's going to be held together by hydrogen bond forces, which turns out to be a molecular lattice as well. The type of lattice is also molecular. So I'm going to keep all of those in the story and see whether we have to differentiate later. Iron is quite clearly a metal, so we are going to land up with a metallic lattice. And we have got diamond, which is a number of atoms held together In a lattice full of atoms, it is called an atomic lattice. So we land up, it's a non-polar covalent bond, admittedly, but it is not a non-polar covalent lattice. It is an atomic lattice. So it turns out that your correct answer is going to be A. Hydrogen and oxygen react with one another to form water according to the following reaction. Brenton has 20 grams of hydrogen and 32 of oxygen. If the reaction goes to completion, what mass of water will Brenton produce? So the first thing we're going to have to work out is the number of moles of hydrogen we've got and the number of moles of oxygen. Mass over molar mass. Hydrogen gas, 1 plus 1 is 2, so I land up with 10 moles of hydrogen gas. I've got 32 grams of oxygen. The molar mass of oxygen is 16 plus 16, so it's 32, so I only have 1 mole. Now I need to consider limiting reagents. I have got 1 mole. If I have 1 mole of oxygen, that means I would need 2 moles of hydrogen. Have I got 2 moles of hydrogen? I have. So I'll have 8 moles left over. That's okay. If I tried to go with 10 moles of hydrogen, I would need 20 moles of oxygen. I don't have 20 moles of oxygen, so I'm going to have to be limited by the number of moles of oxygen that I've got, and then I'm going to take the mole ratio is 1:2 between oxygen and water, or 2:2 between hydrogen and water. So I've got 1 mole of oxygen. I'm going to make 2 moles of water. So number of moles is going to be 2 moles of water. What is the mass? Mass is equal to number of moles times molar mass, which is 2 times the molar mass of water is going to be equal to 1 plus 1 plus 16, which is 18, and I therefore land up with 36 grams of water. Correct answer is